Imagine driving your car 1,300 feet underwater. That's deeper than the Empire State Building is tall. Fish swimming above your roof, crushing ocean pressure all around you, but you're cruising at 50 miles per hour like you're on any regular highway. Norway is spending $2 billion to dig the world's deepest underwater tunnel. Not for trains, not for utilities, for regular cars and trucks. The Rogfast tunnel will plunge 1,300 feet beneath the Norwegian Sea. To put that in perspective, if you stacked 4 Statue of Liberties on top of each other, this tunnel would still be deeper. But here's the part that'll blow your mind. Norway has calculated that this underwater highway will actually make them money. A lot of money. And the way they're building it is so revolutionary that countries around the world are already copying their techniques. Right now, if you want to travel from Stavanger to Bergen in Norway, you have a problem. These 2 major cities are separated by a maze of fjords. Those deep, narrow inlets carved by ancient glaciers. Your journey looks like this. Drive to a ferry, wait, board the ferry, cross the water, get off, drive to another ferry, wait again. Repeat this dance 7 times. What should be a 3-hour drive becomes an 8-hour odyssey, sometimes longer if the weather's bad and ferries get cancelled. Norwegian families have been dealing with this for generations. Business owners lose millions in shipping delays. Emergency vehicles get stuck waiting for ferries while people need help. The ferry companies are making good money, sure, but Norway realized something. They're losing way more money than they're making. Every hour a truck sits waiting for a ferry, that's lost productivity. Every tourist who decides the journey is too complicated, that's lost revenue. Every business that can't expand because transportation is unreliable, that's lost opportunity. So Norway did the math. They calculated that the economic benefit of connecting these regions would pay for the tunnel within 25 years. But building the world's deepest underwater tunnel is not like digging a regular tunnel. At 1,300 feet underwater, the pressure is incredible. We're talking about 40 times normal atmospheric pressure. That's enough to crush a car like a soda can. The rock down there isn't just rock. It's been compressed and twisted by millions of years of geological pressure. Sometimes it's harder than steel. Sometimes it crumbles like cheese. And then there's the water, not just regular groundwater seepage. We're talking about the full weight of the Norwegian Sea trying to flood your tunnel. Most engineers would look at this and say, impossible. Norway's engineers said, challenge accepted. Their solution? Something called the drill and blast method, but supercharged with 21st century technology. They're using explosives so precisely calibrated that they can blast through solid rock without disturbing the tunnel structure just feet away. GPS-guided drilling rigs that can place charges accurate to within inches. But here's the really clever part. They're not fighting the water pressure, they're using it. Traditional underwater tunnels try to keep all water out. Norway realized that's actually the hard way to do it. Instead, they're building what's called a drained tunnel. They're letting controlled amounts of water in, then pumping it out continuously. Think of it like this. Instead of building a completely waterproof submarine, they built a submarine with a really good drainage system. This approach has 3 huge advantages. First, it's way cheaper. You don't need exotic waterproofing materials that cost a fortune. Second, it's actually safer. If your waterproofing fails in a traditional tunnel, you get catastrophic flooding. If your pumping system fails here, you get manageable water flow. Third, it's easier to maintain. You can access and repair the drainage system without major reconstruction. Norway tested this technique on smaller tunnels first. It worked so well that they're now the world leaders in underwater tunnel construction. Countries are literally sending delegations to Norway to learn these techniques. The numbers behind Rogfast are absolutely staggering. They're excavating 8 million cubic meters of rock. That's enough to build a pyramid bigger than the Great Pyramid of Giza. The tunnel will be 27 kilometers long. That's 16.8 miles. You'll be driving underwater for about 20 minutes at highway speed. It will be 4 lanes wide, with emergency exits every 500 meters. Full cell phone coverage throughout. LED lighting that mimics daylight to prevent tunnel fatigue. But here's what really shows you the scale. They're using 15 different construction sites simultaneously. Some on land, some on artificial islands, some on floating platforms. The logistics are insane. They need to coordinate blasting schedules so the explosions don't interfere with each other. They need to transport millions of tons of excavated rock. They need to keep the whole operation running 24/7 to meet their 2033 deadline. And they're doing all of this while maintaining some of the strictest environmental standards in the world. This is where Norway really shows why they're different. Most megaprojects treat environmental protection as an afterthought. Norway made it central to their design. All that excavated rock, they're not just dumping it, they're using it to create new land areas for development. Artificial islands that will become ports, industrial areas, even residential communities. The tunnel ventilation system doesn't just move air, it filters it. The air coming out of the tunnel will actually be cleaner than the air going in. They're also creating artificial reefs with some of the excavated material. These reefs will become new ecosystems for marine life. But the environmental masterpiece is what happens to transportation in the region. Right now, those ferries burn massive amounts of fuel. Diesel engines running constantly, carrying cars and trucks back and forth. The carbon emissions are enormous. Once Rogfast opens, most of that ferry traffic disappears. The reduction in carbon emissions will be equivalent to taking 100,000 cars off the road permanently. Norway is essentially building a tunnel that pays for itself environmentally. But the environmental benefits are just the beginning. Western Norway is economically isolated. Sure, it's connected, but not efficiently. Businesses can't rely on just-in-time delivery. Tourism is limited by transportation hassles. Rogfast changes everything. Shipping companies will be able to guarantee delivery times. Manufacturers can expand their supply chains. Tourists can visit multiple cities in a single trip. But here's the part that most people miss. This tunnel creates a new economic geography. Suddenly, small towns along the route become viable locations for businesses. You can live in a quiet coastal village and commute to Bergen. You can run a manufacturing operation in a low-cost area and still have easy access to major ports. Real estate values are already changing in anticipation. Some areas are seeing property values double. Norway estimates that the tunnel will generate $15 billion in economic activity over its first 20 years. That's a 7-to-1 return on their investment. What Norway is doing with Rogfast isn't just about connecting two cities. They're writing the playbook for 21st century infrastructure. Countries around the world are watching this project because they have similar challenges. China is already adapting Norwegian techniques for underwater tunnels in their Greater Bay Area project. The UK is studying Rogfast for potential connections between England and Northern Ireland. Even the United States is paying attention. There are proposals for underwater tunnels connecting Manhattan to Brooklyn, San Francisco to Marin County. But here's what makes Norway special. They're building smart infrastructure. The tunnel will have sensors monitoring everything: air quality, traffic flow, structural integrity. Machine learning systems that can predict maintenance needs before problems occur. The tunnel's ventilation system adjusts automatically based on traffic patterns and air quality. Emergency response systems can detect accidents within seconds and dispatch help to the exact location. Every single aspect of this tunnel is connected to a central monitoring system. It will learn and adapt over time. Right now, construction is racing ahead. But Norway is facing some serious challenges. Global supply chain disruptions have increased costs by 30%. Skilled tunnel workers are in short supply worldwide. Environmental regulations are getting stricter. The coordination between 15 different construction sites is like conducting a symphony orchestra, where every musician is playing a different song. One delay at any site affects the entire timeline. And there's political pressure. Some Norwegians question whether spending $2 billion on a tunnel is the best use of their oil fund money when they could invest in renewable energy or social programs. But Norway has a secret weapon. They've done this before. Norway already has more underwater tunnels than any other country, over 30 of them. They've learned from every single project. The Lærdal Tunnel taught them about air quality management. The Eiksund Tunnel taught them about deep water construction. The Atlantic Road taught them about building in extreme weather. Rogfast is not their first rodeo, it's their masterpiece. But here's where the story gets really wild. Rogfast is not the end of Norway's underwater highway dreams. It's the beginning. They're already planning the next phase: underwater tunnels connecting Norway to Denmark, then to Germany. Eventually, a completely underwater highway network connecting all of Scandinavia. Imagine driving from Oslo to Copenhagen without ever seeing the surface of the ocean, from Stockholm to Berlin in a straight line under the Baltic Sea. And other countries are making similar plans. Japan wants underwater highways connecting their islands. Indonesia is planning tunnels between their major islands. Even Australia is considering underwater connections to Tasmania. We might be looking at the beginning of a completely new era of transportation, where continents are connected by underwater highway networks. In 2033, when Rogfast opens, you'll be able to drive from one side of Norway to the other in a single day. No ferries, no weather delays, just a straight shot through the deepest underwater highway ever built. But by then, the technology Norway developed for Rogfast will already be spreading around the world. The question is, which country will be brave enough to go even deeper than Norway? And what happens when every major city in the world is connected by underwater highways that make today's transportation look like horse and buggy? Because right now, somewhere in the world, engineers are looking at Norway's success and asking themselves, if they can go 1,300 feet down, why can't we go 2,000? A country famous for 2,500-year-old ruins is about to build its tallest tower ever. Not in booming Dubai, not in gleaming Singapore. In Greece, a nation that has spent decades saying absolutely no to skyscrapers. The Riviera Tower in Athens will be the first domino in Greece's shocking $10 billion transformation plan. This single tower might solve Greece's biggest economic nightmare, or create an entirely new one. For generations, Athens had an unwritten rule: don't build higher than the Acropolis. Imagine telling New York they couldn't build taller than the Statue of Liberty, or Dubai they couldn't go higher than a palm tree. That's essentially what Greece did to itself. Walk through Athens today and you'll see endless rows of 6-story concrete blocks. These aren't charming European townhouses. They're bland, identical apartment buildings that stretch as far as the eye can see. The city looks like someone copy-pasted the same building 1,000 times across the landscape. But there's a reason for this architectural monotony. After World War II, Greece created building codes that essentially banned tall structures. The fear was simple: earthquakes could topple towers. And besides, who wants to compete with the Parthenon? This decision shaped an entire nation's skyline for 70 years. While other countries reached for the clouds, Greece stayed stubbornly horizontal. Then came 2019, and everything changed. The Greek government announced something that shocked architects worldwide. They were approving the Riviera Tower, a 200-meter giant that would dwarf every other building in the country. Think about those numbers for a moment. At 200 meters, this tower is taller than 40 regular houses stacked on top of each other. In a city where most buildings max out at 6 stories, this thing will rise 50 stories into the sky. The tower is completely different from anything Greece has ever attempted. We're talking about luxury apartments that cost more than most Greeks make in a lifetime, office spaces designed for international corporations, and amenities that sound more like Dubai than Athens. But here's where it gets really interesting. This tower represents the first step in Greece's master plan to completely reinvent itself as a luxury destination for the ultra-wealthy. The Riviera Tower is just the beginning. Greece has quietly launched one of the most ambitious urban transformation projects in European history, a $10 billion plan to turn the Athens coastline into a Mediterranean Monaco. The centerpiece? Something called the Hellinikon project. Picture the world's largest coastal urban regeneration project, built on the site of Athens' old airport. We're talking about luxury hotels, shopping districts, residential towers, and a massive park, all designed to attract the global elite. The numbers are staggering. This single project will create 75,000 jobs and add 2.4% to Greece's entire GDP. That's like adding the economic output of a small country to Greece's economy in one fell swoop. But here's the crazy part. Greece is doing this while still recovering from one of the worst economic crashes in modern history. Let's rewind to 2010. Greece was essentially bankrupt. The country couldn't pay its bills, unemployment hit 27%, and young Greeks were fleeing the country in droves. Athens looked less like a European capital and more like a city under siege. Banks were closing, protests filled the streets, and the entire European Union was wondering if Greece would collapse entirely. The word Grexit, Greece exiting the European Union, became a real possibility. Fast forward to today, and Greece is chasing luxury towers and billion-dollar developments. How does a country go from economic disaster to building skyscrapers for millionaires in just over a decade? The answer reveals something fascinating about how nations reinvent themselves in the 21st century. Greece's leaders realized something crucial. You can't rebuild an economy by staying exactly the same. While other European countries competed on manufacturing or technology, Greece decided to compete on something entirely different: lifestyle. The strategy is brilliant in its simplicity. Instead of trying to build factories or tech hubs from scratch, Greece is leveraging what it already has: incredible weather, beautiful coastlines, rich history, and a location that connects Europe to Asia and Africa. But they're not just selling tourism anymore. They're selling a complete lifestyle transformation to the world's wealthy elite. Here's where Greece's plan gets really smart. The country offers something called a golden visa. Invest €250,000 in Greek real estate, and you get European Union residency. Not just Greek residency, access to the entire European Union. For wealthy individuals from China, Russia, the Middle East, and beyond, this is incredibly attractive. You get a luxury apartment in a beautiful Mediterranean country, plus the ability to live and work anywhere in Europe. The Riviera Tower and projects like Hellinikon aren't just buildings. They're golden tickets to European citizenship wrapped in luxury packaging. Since 2014, Greece has issued over 30,000 golden visas, bringing in more than 7.5 billion euros in foreign investment. That's not just pocket change. That's enough money to transform entire regions of the country. But there's another layer to this story that most people miss. Greece's transformation is being funded largely by Chinese investment. The same country that built entire cities from scratch is now helping Greece rebuild its economy through luxury real estate. Chinese companies are pouring billions into Greek infrastructure, ports, and real estate projects. The port of Piraeus, Greece's largest port, is now majority owned by Chinese shipping giant COSCO. Chinese investors are major backers of the Hellinikon development. This creates a fascinating dynamic. Ancient Greece being rebuilt with modern Chinese capital, targeting wealthy global citizens who want European residency. Not everyone in Greece is celebrating these changes. Many locals worry that luxury developments will price them out of their own neighborhoods. Imagine living in the same area your family has called home for generations, only to watch luxury towers rise around you with apartments you could never afford. There's also the cultural concern. Greece has spent millennia preserving its architectural heritage. Critics argue that chasing Dubai-style development risks turning Athens into just another generic luxury destination. The protests haven't been massive, but they're persistent. Environmental groups worry about coastal development. Historians question whether modern towers belong in a city famous for ancient monuments. But perhaps the biggest risk is economic. Greece is essentially betting its recovery on attracting wealthy foreigners. What happens if global economic conditions change? What if other countries offer better golden visa deals? What if the luxury real estate market crashes? Then there's the issue nobody wants to talk about publicly: earthquakes. Greece sits on several active fault lines. The country experiences hundreds of minor earthquakes each year, and major ones every few decades. Traditional Greek buildings were designed low and sturdy for good reason. Now the country is building its tallest structures ever in one of Europe's most seismically active regions. Engineers insist modern technology can handle the risk. The Riviera Tower uses advanced seismic engineering that didn't exist when Greece first banned tall buildings. Computer simulations show it can withstand earthquakes that would level traditional structures. But there's still an element of uncertainty. Greece is essentially conducting a real-world experiment. Can modern engineering overcome ancient geological realities? If the Riviera Tower succeeds, it won't stay alone for long. Developers across Athens are already proposing similar projects. The city's skyline could look completely different within a decade. Other Greek cities are watching closely too. Thessaloniki, Greece's second-largest city, is considering its own luxury development projects. Islands like Mykonos and Santorini are exploring high-end resort expansions. Greece could transform from a horizontal nation to a vertical one within a generation. But Greece isn't operating in a vacuum. Countries across the Mediterranean are competing for the same wealthy international residents. Spain offers golden visas, Portugal has similar programs, and Italy is developing luxury real estate markets. Dubai continues to attract global investment with even more ambitious projects. Singapore offers political stability and business opportunities. Monaco remains the ultimate luxury destination. Greece is entering a crowded market where countries are literally competing to attract the world's wealthy elite. The question isn't just whether Greece can build luxury towers, it's whether those towers can compete with established alternatives worldwide. Here's something most coverage misses. The Riviera Tower isn't just tall, it's smart. The building incorporates advanced technology that would have been impossible when Greece first started avoiding skyscrapers. We're talking about systems that automatically adjust energy consumption, smart elevators that reduce waiting times, and integrated security that uses facial recognition and AI monitoring. The building is designed to be a showcase for how technology can enhance luxury living. It's not just about height, it's about creating a completely different living experience that justifies premium prices. Construction on the Riviera Tower is advancing rapidly. The foundation is complete, and the tower is rising floor by floor. Each month brings Greece closer to a moment that will define its economic future. But here's what makes this story truly fascinating. Greece isn't just building a tower, it's conducting a massive social and economic experiment. Can a nation famous for ancient history successfully rebrand itself as a modern luxury destination? The early signs are promising. Pre-sales for Riviera Tower apartments have exceeded expectations. international investors are paying premium prices for units that won't be completed for another 2 years. Foreign investment in Greek real estate hit record levels in 2023. The Golden Visa program continues attracting wealthy applicants from around the world. Tourism numbers have not just recovered from the economic crisis, they've surpassed pre-crisis levels. Success is creating unexpected consequences throughout Greek society. Property values in Athens have increased dramatically. Young Greeks who couldn't afford apartments during the economic crisis now face even higher prices due to foreign investment. Local businesses are adapting to serve an increasingly international clientele. Restaurants are adding multilingual menus, shops are accepting various currencies, and service industries are hiring staff who speak Mandarin, Arabic, and Russian. Athens is slowly transforming from a purely Greek city to an international hub. Whether this represents progress or cultural loss depends entirely on your perspective. The Riviera Tower should be completed during 2025. When it opens, Greece will officially enter uncharted territory, a nation that spent generations avoiding height suddenly reaching higher than ever before. But the real test isn't whether the tower gets built. The real test is whether Greece's radical transformation actually works. Can a country replace economic ruins with luxury skyscrapers? Can ancient heritage coexist with modern ambition? Can a nation reinvent its entire identity without losing its soul? The answers will determine not just Greece's future, but whether other struggling economies can follow the same playbook. Countries around the world are watching to see if Greece's $10 billion gamble pays off. Because if it works, Greece won't just have built a tower, it will have created a blueprint for national transformation that could reshape how we think about economic recovery in the 21st century. The question isn't just whether the Riviera Tower will stand tall. The question is whether Greece itself will rise or fall with it. Imagine stepping onto a high-speed train in Madrid and arriving in Casablanca just hours later. No flights, no ferries, just solid ground beneath your feet as you travel between two continents. This isn't fantasy. Spain and Morocco are bringing back one of the world's most ambitious tunnel projects. A $10 billion underwater passage that could change everything we know about travel between Europe and Africa. Picture this, you're 475 meters beneath the Mediterranean Sea, deeper than the Empire State Building is tall. Above you, massive cargo ships cross one of the world's busiest shipping lanes. Around you, rock formations that have witnessed the collision of continents for millions of years. This is where Spain and Morocco want to dig the most challenging tunnel ever attempted. The Gibraltar Strait sits at one of Earth's most geologically violent intersections. For the past 6 million years, the African and Eurasian plates have been grinding against each other here, creating a landscape of underwater mountains, deep trenches, and fault lines that stretch for hundreds of kilometers. The water itself tells the story. Atlantic currents flowing east meet Mediterranean currents flowing west, creating an underwater battlefield of competing forces. Every day, over 300 ships navigate these waters. Oil tankers from the Middle East, container vessels from Asia, cruise ships packed with tourists. The strait ranks among the world's busiest shipping lanes, though it represents a smaller fraction of total global maritime traffic. Any tunnel must somehow coexist with this constant parade of massive vessels overhead. The Gibraltar Strait Tunnel isn't new. Engineers have dreamed about connecting Europe and Africa since the 1930s. Back then, Spanish researchers discovered something that killed the project immediately. The rock beneath the strait was so hard that their equipment couldn't even scratch it. The geological surveys revealed layers of limestone and dolomite compressed over millions of years into formations harder than concrete. Early planners considered alternatives. Some proposed a floating bridge with towers reaching nearly a kilometer into the sky. Others suggested an immersed tunnel, prefabricated sections lowered into a trench on the seafloor. Every option faced impossible challenges. The depths were too extreme. The seismic activity too unpredictable. The marine traffic too dense. They gave up. But nearly a century later, the dream is back, and this time they might actually have the technology to make it happen. Modern tunnel boring machines can cut through rock formations that would have destroyed 1930s equipment. Computer modeling can predict geological conditions with precision that early engineers couldn't imagine. Most importantly, successful underwater tunnels now exist as proof that the impossible can become routine. Here's what makes this project absolutely insane. The English Channel Tunnel, which everyone calls impossible when it was built, sits just 75 meters below sea level. The Gibraltar Tunnel will go 6 times deeper at 475 meters maximum depth. While the Channel Tunnel dealt with soft chalk that was relatively easy to dig through, Gibraltar forces engineers to bore through some of the hardest rock on Earth. The strait itself reaches depths of 900 meters, but the tunnel route carefully avoids these deepest sections. The numbers are staggering. 2 parallel tunnels, each around 28 kilometers for the underwater section, with total tunnel length reaching 38 to 42 kilometers, including land approaches. That's like building the Channel Tunnel underwater, but making it shorter while going much, much deeper. The maximum depth hits 475 meters below sea level, deeper than most skyscrapers at all. At those depths, the rock pressure is enormous. The temperatures climb higher than surface levels. Every meter forward becomes a battle against the planet itself. Engineers estimate they'll need to excavate millions cubic meters of rock and sediment. That's enough material to fill thousands of Olympic swimming pools. All of this debris must be transported to the surface through shafts that themselves represent major engineering challenges. The logistics alone boggle the mind. The tunnel boring machines required for this project will be among the largest ever built. Current technology maxes out at around 17.6 meters in diameter for the largest machines currently in operation. Gibraltar's planned tunnels will use machines measuring approximately 7.9 meters in diameter, large but within current technological capabilities. These mechanical beasts would still weigh thousands of tons and cost hundreds of millions of dollars each. But depth isn't even the worst problem. The Gibraltar Strait sits on one of Europe's most dangerous geological features, the Azores-Gibraltar Transform Fault. This isn't just any crack in the earth. This massive fault system stretches over 600 kilometers from the Azores Islands to the coast of Morocco. It represents the active boundary where 3 tectonic plates, African, Eurasian, and Iberian, meet and grind against each other. This fault line produced the devastating 1755 Lisbon earthquake, one of the most powerful quakes in recorded European history. Contemporary accounts describe church bells ringing across Europe from the vibrations. The tremor was so massive that people felt it as far away as Hamburg and even Finland. Lakes in Scotland reportedly sloshed back and forth for hours after the main shock. The resulting tsunami wiped out entire coastal communities across Portugal, Spain, and Morocco. Wave heights reached 15 meters in some areas, taller than a 4-story building. The port city of Lagos in Portugal was partially destroyed. Lisbon's royal palace disappeared beneath the waves. Modern estimates suggest that between 40,000 and 50,000 people died across the region, though some reports put the toll even higher. The fault remains active today. Seismic monitoring stations track regular movements as the African and Eurasian plates slowly grind against each other at about 4 millimeters per year. That might sound tiny, but over the decades it takes to build a tunnel, those forces add up. Engineers must design a structure that can flex and bend with earthquake activity without collapsing. Then there's the water problem. The strait connects 2 different seas, the Atlantic Ocean and Mediterranean Sea. Cold Atlantic waters constantly flow eastward, while warm Mediterranean waters flow westward, creating powerful underwater currents. These currents reach speeds that can knock diving equipment off course. Building tunnel sections in these conditions requires precision that has never been attempted at such depths. The water exchange between these seas is massive. Every second, roughly 1 million cubic meters of water flows through the strait. That's equivalent to emptying an entire Olympic swimming pool every 2 seconds, continuously, forever. This constant flow creates complex underwater weather patterns that change with tides, seasons, and atmospheric pressure. Marine life adds another layer of complexity. The strait serves as a critical migration corridor for whales, dolphins, and countless fish species. Sperm whales dive to depths of 1,000 meters here, hunting for giant squid in the deep trenches. Pilot whales travel in pods of hundreds. Any construction activity must account for these sensitive ecosystems. The underwater topography resembles an alien landscape. Steep underwater cliffs drop into abyssal plains. Rocky pinnacles rise like underwater mountains. The Cameronal Sill, an underwater ridge that separates the Atlantic from the Mediterranean, reaches depths of only 280 meters at its shallowest point. This ridge controls the water flow between the seas and represents one of the most challenging sections for tunnel construction. Spanish and Moroccan governments officially launched this project back in 1979 when their king signed an agreement to strengthen relationships between Europe and Africa. Two state companies formed, SECEGSA in Spain and SNED in Morocco. They spent millions on studies throughout the 1980s, but by 2009, the project died again. Too expensive, too risky, too complicated. What changed? The 2030 World Cup. Morocco, Spain, and Portugal will co-host the first World Cup ever held across two continents. Suddenly, connecting Europe and Africa by land became more than an engineering fantasy. It became a political necessity, tourism revenues, national pride, global attention. However, the tunnel will not be ready for the 2030 World Cup. Current projections put completion at 2040 or later. The numbers are compelling. FIFA estimates that the 2030 World Cup could attract over 5 million international visitors across the three host countries. Traditional travel between Spain and Morocco involves either flying or taking ferries across the strait. Flights require airport transfers, security delays, and weather-dependent schedules. Ferries take 35 minutes for the crossing, but require additional time for vehicle loading and port procedures. While the tunnel won't serve the 2030 World Cup, the tournament has created political momentum for the project. A high-speed rail tunnel would eventually revolutionize travel patterns between the continents. Journey times from Madrid to Casablanca could drop to under 4 hours, competitive with flying when you factor in airport delays. The economic impact extends far beyond tourism. Spain and Morocco have been strengthening trade relationships for decades. Morocco now ranks as Spain's fastest-growing trade partner in Africa. Spanish companies have invested heavily in Moroccan automotive manufacturing, renewable energy, and telecommunications. A direct rail link would accelerate these trends dramatically. Morocco's high-speed rail system changes everything. In 2018, Morocco launched Al Barak, Africa's first high-speed train. These sleek machines hit 320 kilometers per hour, connecting Tangier to Casablanca in just over 2 hours. The journey that once took nearly 5 hours by conventional rail now happens faster than most people's morning commute. Al Barak represents more than just fast trains. The entire system was designed with European integration in mind. The trains use French TGV technology adapted for Moroccan conditions. The electrical systems operate on the same standards as Spain's high-speed network. Even the track gauge matches European specifications perfectly. The investment was massive, over $2 billion for the initial 200-kilometer line, but the results speak for themselves. Al Barak has transported over 6 million passengers since opening, with ridership growing steadily each year. Business travelers now routinely commute between Morocco's major cities. Tourists can easily visit multiple destinations in a single trip. Current expansion plans are even more ambitious. Morocco is extending the high-speed line south to Marrakesh by 2029, adding another 430 kilometers of track. Eventually, the network could reach all the way to Agadir on the Atlantic coast, creating a 1,500-kilometer high-speed rail system spanning the entire country. Al Barak uses the same electrical systems and track gauge as Spain's high-speed network. That's not coincidence. Moroccan planners always intended their trains to eventually cross into Europe. The infrastructure already exists on both sides. The tunnel just needs to connect them. Current plans call for the tunnel to link Punta Paloma in southern Spain with Malabarta near Tangier in Morocco. That route avoids the deepest parts of the strait while still providing the shortest possible crossing. Trains would carry both passengers and vehicles, similar to the Channel Tunnel's shuttle service. But let's talk about what this really means. The tunnel would create the first permanent land connection between Europe and Africa since the continents separated millions of years ago. Trade routes that currently depend on slow maritime shipping could switch to rapid rail transport. A container leaving Morocco could reach Berlin faster than current sea routes reach London. The economic possibilities are massive. Morocco serves as a gateway to all of Africa. The country has become a major automotive manufacturing hub, producing car parts for European brands like Renault, Peugeot, and Ford. Moroccan factories now export over $10 billion worth of automotive products annually. With a direct rail link, these factories could integrate even more closely with European supply chains. Agriculture represents another huge opportunity. Morocco produces citrus fruits, vegetables, and other crops that European markets demand year-round. Currently, these products travel by truck to ports, then by ship to European destinations. A rail tunnel could cut transport times dramatically while reducing costs and environmental impact. The logistics industry is already preparing for this transformation. Major shipping companies are studying how a Gibraltar tunnel would affect their European-African routes. Some predict that rail transport could capture 30% or more of current maritime cargo volumes on certain routes. Tourism works both ways. European visitors could easily explore Morocco's imperial cities, Marrakesh, Fez, Casablanca, without the hassle of airports or ferry terminals. Weekend trips to Marrakesh from Madrid could become as common as Paris to London excursions. Meanwhile, North African tourists could access Europe's attractions with unprecedented convenience. The cultural implications are equally profound. A permanent land link would accelerate the exchange of ideas, languages, and traditions between continents. Students could easily study abroad. Workers could commute between countries. Families separated by the strait could maintain closer connections. Recent diplomatic developments make the tunnel more likely than ever. In late 2024, French President Emmanuel Macron visited Morocco for the first time in 6 years, signing agreements worth €10 billion. These deals specifically include expanding Morocco's high-speed rail network southward to Marrakesh, scheduled for completion before the 2030 World Cup. Funding remains one of the biggest challenges. Unlike the Channel Tunnel, which was privately financed, the Gibraltar project will likely require massive government investment from both Spain and Morocco. The European Union has already contributed for feasibility studies, suggesting potential support for the full project. International development banks are watching closely. The African Development Bank and European Investment Bank both funded Morocco's Al Barak high-speed line. These institutions could provide crucial financing for the tunnel project, especially given its potential to boost economic development across North Africa. Private investors are also expressing interest. Major construction companies like Bouygues, Vinci, and ACS have the expertise and financial resources to participate in such mega projects. The promise of decades-long operations and maintenance contracts makes the tunnel attractive despite the enormous upfront costs. The engineering challenges remain brutal. Swiss firm Lombardy Engineering, which helped design the Channel Tunnel, studied the Gibraltar project in 2006. Their conclusion? Technically possible, but far more complex than anything attempted before. The presence of 2 deep clay channels halfway across the strait complicates construction. These soft sediment layers could cause tunnel boring machines to get stuck or damaged. Modern tunnel boring technology has advanced significantly since 2006. The latest machines include sophisticated ground-penetrating radar that can detect geological changes ahead of the cutting face. Computer-controlled steering systems can adjust the tunnel path in real time to avoid obstacles. Improved cutting tools can handle mixed geological conditions that would have stopped earlier machines. The machines themselves are marvels of engineering. A typical tunnel boring machine for this project would measure around 7.9 meters in diameter and extend 200 meters in length, matching the technical specifications in current tunnel plans. These mechanical monsters weigh up to 4,000 tons and cost around €100 million each. They operate like underground factories, simultaneously excavating rock, installing concrete tunnel lining, and removing debris through conveyor systems. Seismic activity requires entirely new approaches to tunnel design. Traditional rigid concrete tunnels would crack during earthquakes. Engineers are exploring flexible joint systems that allow tunnel sections to move independently. Think of it like a giant underground snake that can bend without breaking. These joints must remain watertight while accommodating movements of several centimeters during major earthquakes. Japanese engineers have pioneered many of these techniques in response to their country's frequent seismic activity. The Seikan Tunnel, which connects Japan's main islands, operates successfully in one of the world's most earthquake-prone regions. However, the Seikan Tunnel reaches maximum depths of only 240 meters, half the depth planned for Gibraltar. Water pressure at maximum depth reaches levels that would crush conventional tunnel designs. The concrete walls need to be thick enough to withstand pressures equivalent to having several elephants standing on every square meter. Specialized waterproofing systems must prevent even tiny leaks that could gradually flood the tunnel. Temperature management becomes critical at such depths. Rock temperatures rise significantly below ground. Add the heat generated by high-speed trains, electrical systems, and ventilation equipment, and the tunnel could become dangerously hot. Cooling systems must operate continuously to maintain safe conditions. Emergency procedures require completely new thinking. If something goes wrong in the Channel Tunnel, rescue teams can reach any point within 30 minutes. In the Gibraltar Tunnel, the deeper sections could take much longer to access. Escape routes, emergency chambers, and backup systems must account for the extreme environment. Current construction timelines no longer target 2030. Recent reports suggest completion has slipped to 2040 or later, which is probably realistic given the enormous technical challenges. The Channel Tunnel took 6 years to build through relatively simple geology. Gibraltar's harsh conditions could easily extend that timeline significantly. The geopolitical implications extend far beyond transportation. A permanent link between Europe and Africa would fundamentally alter trade relationships and cultural exchange. European leaders see Morocco as a stable partner in an increasingly unstable region. The tunnel represents a massive bet on continued cooperation. But criticism exists too. Environmental groups worry about disturbing sensitive marine ecosystems. The strait supports diverse wildlife, including migration routes for whales and dolphins. Construction activities could disrupt these patterns permanently. Some economists question whether the tunnel makes financial sense. High-speed rail works best for distances between 200 and 800 kilometers. Beyond that range, aircraft become more competitive. Madrid to Casablanca covers about 900 kilometers, right at the edge of rail's effectiveness. Security concerns also loom large. A permanent land connection between continents could facilitate illegal immigration or smuggling. Border controls would need to be absolutely airtight. Any security failure could undermine political support for the entire project. Technical alternatives exist. Some engineers propose floating tunnels, underwater tubes anchored to the seabed but not buried beneath it. These structures could avoid the deepest rock formations while still providing a fixed crossing. However, floating tunnels have never been built at Gibraltar's scale or depth. Bridge options remain technically impossible. The strait's 900-meter depth would require support towers taller than any structure ever built. The seismic activity and marine traffic make bridges completely impractical. If this crossing gets built, it will definitely be a tunnel. Regional competitors are watching closely. Turkey is building massive infrastructure projects connecting Europe and Asia. Russia has discussed tunnels across various straits. China's Belt and Road Initiative includes multiple underwater crossings. The Gibraltar Tunnel represents Europe's answer to these ambitious connectivity projects. Looking ahead, success depends on sustained political will from both governments. Megaprojects typically span multiple election cycles. New leaders must remain committed to their predecessors' visions. Economic crises, political instability, or diplomatic tensions could easily derail the project. Technical advances in tunneling technology improve the odds. Tunnel boring machines have become larger, more powerful, and more precise since the Channel Tunnel era. Computer modeling can predict geological conditions with unprecedented accuracy. These improvements might make Gibraltar's challenges manageable. The 2030 World Cup provides a firm deadline that concentrates minds and budgets. Major sporting events have historically driven infrastructure development. Japan built its bullet train network for the 1964 Olympics. China constructed massive transportation systems for the 2008 Olympics. Morocco, Spain, and Portugal have similar motivation for 2030. Whether the tunnel actually gets built depends on factors beyond pure engineering. Political stability, economic growth, technological advances, and international cooperation must all align perfectly. The margin for error remains extremely thin. Current feasibility studies project the tunnel could carry approximately 12.8 million passengers annually, though these remain estimates subject to change as the project develops. That's roughly the population of Belgium crossing between continents every year. Freight capacity projections suggest the tunnel could handle significant portions of Europe-Africa trade, though exact volumes depend on pricing and logistics arrangements. The economic impacts would ripple across both continents. But we've heard ambitious promises before. The 1930s studies promised a Gibraltar crossing within decades. The 1980s revival generated similar optimism. Previous generations of engineers couldn't deliver. This generation faces the same fundamental challenges, plus new complexities. The Gibraltar Tunnel represents a boldest attempt to reshape geography through engineering. Success would create the first permanent link between Europe and Africa since the continents separated. Failure would remind us that some barriers exist for good reasons. With just 5 years until the 2030 World Cup, we're about to discover whether modern technology can finally conquer one of Earth's most stubborn obstacles. Let us know what you think about this in the comments section. The question isn't whether we can dig through 900 meters of rock beneath one of the world's most active seismic zones. The question is whether we should, because once you connect two continents, there's no going back. Monaco is the world's second smallest country. So tiny, you could walk across it in under an hour, yet it's home to more billionaires per square mile than anywhere else on Earth. When this ultra-wealthy microstate ran out of space, it launched a $2 billion megaproject to push back the Mediterranean Sea itself, the Mareterra. This expansion isn't just creating new luxury real estate, it's redefining what's possible when unlimited wealth meets engineering innovation. Monaco's problem is simple: it's running out of room. At just 0.78 square miles, this microstate is smaller than New York's Central Park, yet it packs in 39,000 residents, making it the most densely populated country on Earth. But density isn't the real story here. It's who lives in Monaco that matters. 1 in 3 residents is a millionaire. The average price for a home? $5.2 million. Want a decent-sized apartment with a sea view? That'll be $30 million. The math is brutal. When you're wedged between mountains and sea, with every inch of land already developed, how do you keep growing? How do you house the yacht-owning elite who fuel your economy? For Prince Albert II, the answer was clear. If you can't expand outward or upward, expand into the ocean itself. This isn't just about luxury apartments. Monaco's economy depends on attracting and keeping the ultra-wealthy. Without room to grow, the principality risks losing its competitive edge to other tax havens around the world. This isn't Monaco's first attempt at naval conquest. Since the 1950s, the principality has reclaimed nearly 20% of its territory from the Mediterranean, including the glamorous Lavotto Beach District and the land that hosts its famous Formula One Grand Prix. The Fontvieille district, completed in 1981, added 0.08 square miles, a massive 10% increase to Monaco's territory. Built under Prince Rainier III, known as the Builder Prince, this project transformed a mostly barren rock outcropping into prime real estate that now houses 3,000 residents. But the new Mareterra project is different. Previous reclamations were essentially just fill and build operations. Dump rocks and concrete into the sea, flatten it out, and start construction. That approach doesn't work anymore. Not when Monaco's ruler positions himself as an environmental champion. Not when the Mediterranean ecosystem is already under immense pressure from climate change, overfishing, and pollution. The $2 billion price tag isn't just buying land, it's buying a new approach to expansion that attempts to balance luxury with sustainability. The Mareterra expansion covers 15 acres, that's about 15 football fields, extending Monaco's coastline by nearly 500 feet into the Mediterranean. But the real engineering magic happens underwater. Unlike traditional land reclamation that simply pours concrete and rocks onto the seabed, Mareterra sits on a foundation of 18 massive concrete caissons. Each one is 7 stories tall and weighs 10,000 tons. Manufactured on land, then towed out to sea and sunk into precisely mapped positions. The logistics alone are staggering. Each caisson required 3,800 cubic meters of concrete, enough to fill an Olympic swimming pool. A specialized factory was built just to produce these massive structures, which were then transported by barge to their final locations. These hollow concrete boxes weren't just dropped onto the seabed. Engineers first had to remove 500,000 cubic meters of unstable soft soil and replace it with a more stable foundation. Every step had to account for potential earthquakes, as Monaco sits in a seismically active region. The design also needed to withstand the Mediterranean's increasingly violent storms, a direct consequence of climate change. Computer models simulated 100-year storm events, ensuring the structures could withstand waves up to 8 meters high. The caissons themselves were designed with holes and textured surfaces to encourage marine life to colonize them. Within months, these artificial structures began transforming into artificial reefs, an attempt to mitigate the environmental impact of the project. Once the caissons were in place, the space between them and the original shoreline was filled with 1.5 million tons of sand imported from quarries in northern Italy. This wasn't just any sand. It was meticulously selected to match the composition and color of Monaco's existing beaches. Is it enough? We'll explore that question later. But first, let's look at what Monaco is actually building on this reclaimed land. When you're already the world's wealthiest nation per capita, your new neighborhood can't just be nice. It has to be extraordinary. Mareterra will house approximately 1,000 ultra-wealthy residents in 120 luxury apartments. The centerpiece is a striking sailboat-shaped skyscraper designed by renowned architect Renzo Piano, a deliberate nod to Monaco's maritime heritage. Piano's design isn't just aesthetically pleasing, it's functional. The building's curved shape minimizes wind resistance, crucial for a structure built on artificial land. Its sail-like facade incorporates photovoltaic panels that generate up to 40% of the building's energy needs. Surrounding this centerpiece are 6 smaller residential buildings, each designed to maximize natural light and minimize energy consumption. Every apartment has a sea view, a must-have feature when prices start at $100,000 per square meter. But the real selling point isn't just the architecture, it's the green credentials. The district is designed to be carbon neutral, with solar panels, seawater heat pumps, and rainwater recovery systems. Buildings feature living walls and rooftop gardens. There's even a small artificial hill, a rarity in space-starved Monaco, creating a public park that overlooks the Mediterranean. The project includes a sophisticated waste management system that sorts and processes trash underground, eliminating the need for garbage trucks. Smart sensors monitor air quality, water usage, and energy consumption in real time, adjusting systems for maximum efficiency. Cars? They're banished underground. The entire district is pedestrian only, with vehicles accessing apartments and businesses through a network of subterranean tunnels. Electric shuttles provide transportation within the district, connecting to Monaco's existing public transit system. For Prince Albert II, this eco-friendly approach isn't just marketing, it's personal. As an oceanographer and environmental advocate, he's positioned Monaco as a leader in marine conservation. Mareterra is his attempt to prove that development and environmental stewardship can coexist. But can a project that fundamentally alters the coastline ever truly be sustainable? From the beginning, Mareterra faced fierce opposition from environmental groups. Their concerns were straightforward. Any artificial extension into the sea would disrupt marine ecosystems. The project site overlapped with a protected Posidonia seagrass meadow, underwater plants crucial for marine biodiversity and carbon sequestration. These lungs of the Mediterranean take centuries to grow and are already threatened throughout the region. 1 square meter of Posidonia can produce 14 liters of oxygen daily and support up to 300 different species. Destroying these meadows doesn't just harm local marine life, it contributes to climate change by eliminating a natural carbon sink. Monaco's solution? Carefully transplant the seagrass to a new protected area before construction began. Teams of divers painstakingly moved over 500 square meters of seagrass to a nearby marine reserve. The Principality also funded the creation of artificial reefs and marine protected areas to offset the project's impact. More than 600 concrete structures were placed on the seabed to create new habitats for displaced marine life. Additionally, Monaco committed $35 million to marine conservation projects throughout the Mediterranean. This included funding research expeditions, supporting marine protected areas in neighboring countries, and launching educational programs about ocean conservation. Critics argue these measures are mere window dressing, that you can't truly compensate for permanently altering the coastline. The transplanted seagrass has only a 50% chance of survival, according to independent marine biologists. And artificial reefs, while beneficial, can't replace the complex ecosystems that evolved naturally over thousands of years. But Monaco's defenders point to the project's strict environmental monitoring system, which tracks water quality, marine biodiversity, and ecosystem health in real time. Any significant negative impacts trigger immediate mitigation measures. The reality lies somewhere in between. Mareterra represents a significant improvement over Monaco's previous land reclamation projects, but it still fundamentally changes the natural coastline. The question isn't whether it has an environmental impact, it's whether that impact is justified by the Principality's desperate need for space. At $2 billion for 15 acres, Mareterra costs roughly $133 million per acre, making it some of the most expensive real estate ever created. The numbers are staggering. The caisson foundation alone cost $450 million. Environmental mitigation added another $200 million. The specialized construction techniques required to build on reclaimed land added a 40% premium to building costs compared to construction on natural land. But Monaco's government expects to recoup this investment many times over. The apartments alone are projected to sell for over $100,000 per square foot, more than double the average price in Monaco's existing luxury market. The math works out to approximately $3.5 billion in residential sales alone. Add in commercial space, parking garages, and marina berths, and the total revenue could exceed $5 billion, a 150% return on investment. For buyers, these prices make sense. Monaco offers a powerful combination of security, privacy, and most importantly, tax benefits. With no income tax, no capital gains tax, and no property tax, the Principality is a haven for the ultra-wealthy. A billionaire who purchases a $50 million apartment in Mareterra might save that much in taxes within just a few years of residency, making the property essentially free in the long run. The economic ripple effects extend beyond real estate. The project created over 2,000 construction jobs and will eventually support hundreds of permanent positions in retail, hospitality, and property management. Mareterra also includes a small technology incubator, part of Monaco's effort to diversify its economy beyond banking and tourism. The Principality hopes to attract fintech and green tech startups, offering tax incentives and state-of-the-art facilities. For Monaco, the math is simple. Without expansion, growth stalls. And in the high-stakes world of tax havens, standing still means falling behind competitors like Singapore, Dubai, and the Cayman Islands. But land reclamation has its limits. Even with its new addition, Monaco remains tiny. The Principality has already built upward, with skyscrapers dominating its skyline. It's built downward, with underground parking garages and shopping centres. Now, it's building outward into the sea. What happens when these options are exhausted? That's where Monaco's next frontier comes in. Monaco is already planning its next expansion, but this time, the vision is far more radical. Floating neighbourhoods that don't just extend the coastline, but create entirely new real estate above the waves. Early concepts show modular floating platforms that can be expanded or reconfigured as needed, a solution that could potentially cause less environmental disruption than traditional land reclamation. These floating structures would be anchored to the seabed, but rise and fall with the tides. Preliminary designs include underwater observation areas, allowing residents to live both above and below the water's surface. Is this the future of urban development in coastal cities facing rising seas and limited space? Or is it another example of how the ultra-wealthy live by different rules than the rest of us?